Welcome to our review on atomic structure. First thing we need to consider is thinking about the size of atoms. And when we're talking about the size of an atom, we're talking about something that's given to us by the atomic radius. The other thing we may need to consider is the length of a bond, which quite simply is the distance between the centres of two joined atoms. And what we find conveniently is that the atomic radius and the length of a bond are actually about the same, which is around 1 × 10⁻⁻10 meters or 0.1 nanometers. As we've seen in a previous video, this is the structure of the atom as we know it today. So we have the nucleus in the center made up of our protons and neutrons, with the electrons in those shells around it. And if we were to actually take the radius of just the nucleus, then we find that it's a very tiny 1 × 10⁻14 meters. So tiny little size there for the nucleus. One of the old favourite exam questions is asking you about the details to do with our subatomic particles. And there are two things you need to know about the subatomic particles. You need to know their relative mass and their relative charge. So if we think about a proton first of all, that's got a relative mass of 1 and the relative charge is +1. The neutron has a relative mass of 1 and a relative charge of 0, so think neutron, neutral. And then the electron, its relative mass is very small. If you want to be a little bit more specific, it's 1/2000, and the relative charge is -1. So make sure you know the charges and the masses for the 3 subatomic particles. As we've seen previously, we've looked at the periodic table and seen that each of those squares gives us 4 bits of information. The symbol and the name in the middle, and then we've got the atomic number, which is the smaller of the 2 numbers in the box, and the mass number is the larger of the 2 numbers in the box. So what do those phrases actually mean? Atomic number tells us the number of protons or the number of electrons, because atoms are neutral. Therefore, the number of protons is the same as the number of electrons. The mass number tells us the number of protons plus the number of neutrons. So how can we use this? They could ask you to write down how many protons, electrons and neutrons there are in any given element from the periodic table. And the way we do this is actually really quite simple. So on the periodic table you get in your AQA exams, then you have a key smack bang in the middle telling you which is the atomic number and which is the mass number, just in case you forget. So if you need to know how many protons or electrons there are, look at the atomic number and just write it down. So in this case, we've got 81 protons and 81 electrons. If we need to work out the number of neutrons present, all you need to do is the mass number minus the atomic number. So in this case, 204 minus 81 gives us 123 neutrons. Hopefully at the end of this video you can now recall the 3 subatomic particles, their masses and charges, and you can also work out the number of protons, electrons or neutrons present within any element on the periodic table.